Welcome back, fellow scientists. I'm so excited to get to make this video for you, although I will be completely honest, I don't do this very often. This is actually the first video that I've made in years. Like, it's been years, so I'm a little bit anxious. I don't know why, but I'm kind of freaking out. So, bear with me. We'll get through this. So, what have we been talking about? Yep, we've been talking about cellular respiration, right? We went through glycolysis and its steps. We went through the Krebs cycle and all its steps. We went through the electron transport chain and that whole process. And then we also talked about fermentation, which is the video you guys just watched. And all of those processes, the whole point is to make ATP, right? So we are making ATP. And the question we're asking today is how cellular respiration helps us become a better athlete, or actually even gives us the ability to be an athlete to begin with. So, the first place that our body accesses the ATP from when we're going to exercise or we need to move quickly is from the ATP that's already stored in our muscles. So let's put that down. We'll put it actually below this little image here. So, the ATP stored in our muscles. So there's a little bit. There's not a lot, though. And so the ATP that's stored in our muscles allows us enough energy to move really quick, like a couple second burst of movement, all right? So let's move this down here. So for instance, let's say you are walking along a path in the woods, right? And there's trees all over the place. And all of a sudden you hear that a branch broke and it's coming down. The ATP in your muscles will give you enough energy to jump out of the way. It's just a couple seconds, but you jumped out of the way and now you're safe. And that's why. So you're safe now, right? So this allows enough energy for quick bursts of movement. This is not enough energy to be an athlete, right? I mean, quick bursts of movement, you wouldn't be able to do anything on the floor, on the court. It'd like be enough for you to like step out onto the basketball court, or to step out onto the soccer field, or to like jump into the water if you're swimming. But it wouldn't give you enough to actually prolong activity, right? So our body uses respiration for that, which we've been talking about, right? And there's two types, anaerobic and aerobic. Now, anaerobic respiration in our bodies, when you combines both fermentation and glycolysis, which you just watched about in our previous video. So we're going to talk about that. So the next way so here we have a little, right here, we have our nice little tired guy, and we'll talk about that. So our bodies can use ATP produced with anaerobic respiration. So we have anaerobic respiration. Okay, and that produces 2 ATP, because as we talked about in the video, what happens during fermentation is you end up with your NAD+, which is your empty baskets, and so it can go back into the process of glycolysis and you can get 2 ATP from that, all right? That ATP is enough to sustain about 90 seconds of activity. If you were sprinting and you didn't have to go very far, that would get you there. That's enough energy to get you there. And remember, it being, oops, I went a little bit too far. Anaerobic, it doesn't require oxygen, right? So this is like if you're a sprinter and you're sprinting. So let's say you're doing like 100 meters to like 400 meters, or even like to 800 meters. This might be enough ATP to get you that full 800 meters if you're really fast. I'm not that fast. I'm a really slow runner. But this is just for that quick, you're sprinting, you got 90 seconds, you're going to just move from point A to point B really, really fast. But this is not enough ATP for a prolonged, like, mile run, or a basketball game, or a soccer game. So we have to use another process, which is aerobic respiration, and we'll get to that in just a second. Going back to fermentation really quick, and anaerobic here, our little guy, he looks like he's huffing and puffing, right? He is just out of breath. The reason that is because as we're using fermentation and anaerobic respiration, our body is developing an oxygen debt. And what happens is, so lactic acid is produced, and we talked about how in regular fermentation, alcohol is produced, but in our bodies, through anaerobic respiration, lactic acid is produced, okay? And it builds up. So it builds up. And in order for it to be removed, it needs oxygen. So, move it down. There we go. It needs oxygen, it needs O2. So let's say you, all right, when your body is using anaerobic respiration to provide ATP for that, it's building up lactic acid. Your body wants to get rid of it, and so that'll leave you huffing and puffing for like 1 to 2 minutes as your body tries to replace that oxygen that it needs to remove the lactic acid. All right. So again, we've just talked about 2 ways your body gets ATP for quick movement or for short-term movement. But how do we become better athletes? How can we play a whole game of basketball or go run a marathon? How do we do that? Where do we get the ATP for that? What have we been talking about? Cellular respiration. That's right. So let's go over here. So this is aerobic cellular respiration. Oh, my pen stopped. Where did it go? It's freezing. Oh no. Oh, I'm back. I stopped for a second. I went away. So the way that our bodies gets enough ATP for prolonged activity is through aerobic cellular respiration. Whoops. All right. So remember, let's kind of go back and quickly talk about our cellular respiration byproducts, right? As we're moving through the process, how much ATP do we get with? Do we end up with? Do you guys remember? If we count them up, we get somewhere between 36 to 38. However, as Cellular mentioned, really with all the new technology we have, we realize it's really more accurately only between 30. But this ATP that's produced is what gives us enough energy to keep going. Whoops. I don't need that. I always have technology issues. You guys realize this, right? I'm learning, but it's kind of a slow process sometimes. So we now have, with aerobic cellular respiration, we've gone through glycolysis, Krebs, the electron transport chain, and we get 30 to 32 ATP, okay? And this gives us enough energy for sports and to become better athletes. All right, so when we're comparing this to like anaerobic respiration, which we can only move about 90 seconds with, that only gets us 2 ATP. This gets us 32 ATP. So this is how we keep moving, all right? So let's go like bigger picture now. We're gonna branch out a little bit. So we're just talking about ATP and how it's produced. Now I want to talk about get a little bit bigger picture. So over time, in order for glycolysis to occur, for it to start, we have to have sugar, right? So remember, glycolysis starts with sugar. Glycolysis, and it starts with glucose. So where does that glucose come from, right? That's a good question. We have in our muscles, so our muscles have enough glucose, which is stored in glycogen. So write down glycogen, which is a polymer of glucose, and it gets broken down so that it can be used in glycolysis for about 20 to 30 minutes of activity. Okay, so when you're thinking about going and exercising, okay, and let's say you're going to go run on the treadmill, you can run for about 20 to 30 minutes just simply using the glycogen storage in your muscles. And your body will convert that into ATP, into glucose, which can then go through cellular respiration process, and you get ATP from it, and you can just keep on going. However, after that, the glycogen runs out, and your body starts breaking down fat. So after 30 minutes, So after 30 minutes, your body accesses other sources. Like fat. Which is why, let's see if I can move this down, there we go. Which is why when, like, if you have a trainer and you're trying to lose weight, if your goal for exercise is to lose weight, let's say, I'll write that down. You're going to want to exercise, do aerobic activity for like at least 30 minutes and sometimes an hour. And that will, what that does is that uses up the glycogen, and then you start breaking down fat so you can actually lose weight. So what you want to do to become a better athlete is to look at your workout, what type of workout you want to do, okay? So again, if your goal is to lose weight, you want to do aerobic activities like running, swimming, playing sports like basketball or soccer, where you're going to be exercising for more than 20 or 30 minutes. You're going to start breaking down fat, and that's going to help you lose weight. But sometimes your workout goal is to increase muscle mass. So if your goal is to muscle mass, muscle mass is increased through like short, quick bursts. And for that, actually, anaerobic respiration will sometimes allow you to do that in really short bursts of activity. But you just use your muscles differently when you have different workout goals. All right, so that's how you become a better athlete with cellular respiration. It's what gives you the ability to have prolonged activity because you're making enough ATP for your body to just keep on functioning. All right, thank you, fellow scientists. I will see you next time.